Hello everyone, welcome to Foodset. Today we will discuss about the colorimeter, how it's important to food product analysis. Okay, so let's start. First we go with the theory. Colorimeter are instruments designed for measuring and analyzing the color of various objects such as liquids, powders, or solid surfaces. These devices are commonly used in industries like food, paper, textiles, and plastics to ensure consistent and accurate color quality. Working principle. The working principle of these colorimeters involves the measurement of the intensity of light reflected or transmitted by the sample at different wavelengths across the visible spectrum. What is visible spectrum? Visible spectrum is the electromagnetic spectrum, which is ranges between the 400 to 700 nanometer. Why we consider here only visible spectrum? Because the human being can see only the visible spectrum part. That is why it is selected only visible spectrum. Here is a general overview of the working principle. First one is the light source. A light source means it uses that basically it's white light which covering all the visible region, means 400 to 700 nanometer. Filters or wavelength selection. Filters are usually used here to isolate the light at based on the wavelength. Sample interaction. When the light falls on the sample absorbs or reflects light based on its color. Detector, what does it do? Actually, what are the reflected or transmitted lights from the sample? The detector collects from that lights. Okay, and in signal processing, it uses the data collected by the detector and it converts is in the light value, that is the L string, A string, and B string based on the CIE color model. CIE is the sorry, the full form of CIE is the International Commission on Illumination. After signal processing, the data will display on display. Then the geometries used in colorimeter. There are four geometries which is used in the colorimeter. First one is the diffuse illumination and light collection at normal. Normal means at 0 degree. Okay, so here the illumination is done in the diffusion way. Okay, it will diffuse the light and the data is collected by the detector at 0 degree. It's opposite. It's normal illumination and diffuse light collection. Third one is the illumination at 45 degree and light collection at the normal. That means 45 degree we illuminate and we collect the data through detector, but at the 0 degree. That means this is showing the light source. Okay, that is the illumination which is at 45 degree on the sample, and whatever the light reflected through this sample is collected through the detector at 0 degree, and vice versa also, that normal illumination and light collection at 45 degree. So what here is do that illuminating at 0 degree on the sample, and here from the sample it is reflected, the detector collects all the reflected lights at 45 degree. See the color values. So here allistic, aistic, and basic I told about you. So allistic ranges between the 0 to 100. If it is 0, that means it is completely dark. If it is 100, that means it is white. Okay. For aistic, it is ranges between minus 128 to 127. If it is negative, that means it is green. Or and if it is positive, that means it is red. And for a B strip value, its value ranges its value also ranges between minus 128 to 127. That indicates about the blueness to yellowness. In this figure you can clearly see that that 0 strip value is 0, that means it's going towards the white. And if it is sorry, if it is 100, then it's going towards white. If it is 0, that it means it is going towards the black. For A stick value, see, for positive value it's becoming red for positive A streak, and for negative A streak it's becoming green. For B value, the positive B streak value going is becoming yellow as it is increasing, and the negative B streak value it becoming blue. Next one, let's see the example of that tomato. One is red tomato, another one is orange color tomato. Okay, so first you have to measure the color of that red color tomatoes. See from, for example, the elastic value is 43.31. A stick value is 47.63 and B stick value is equals to 14.12. And for orange color tomato, the L stick, A stick, and A stick value are given. If you put this value on this formula, you will get the overall color changes. See, visually we can see that it's a red color and it is orange color. But if you have to say, if you have to tell the value, numerical value, so you have to measure it through the colorimeter, and this value you will get. And that if you put that value, then you can numerically tell that there is that much difference on the red colored and orange colored tomato. Next one is the hue angle. Actually, in previous figure here you can see that all the L stick, A stick, and B stick value. If you see that circle, that is the color circle. Okay, so hue angle basically tells about the position of the color. Suppose it is 0 degree, that means it tells about the red color. Okay, if it is 90 degree, that tells about the yellow color. If it is 180 degree, that tells about the green color. And if it is blue color, that tells about the at 270 degree, it tells about the blue color. How you can measure the hue angle? Hue angle can be measured, hue angle is equals to arc tan B by A. That means nothing but the tan inverse B strict and A strict value. That B and A value you will get from the colorimeter values. Okay. And as you can see from this figure, this value range of hue angle ranges between the 0 to 360 degree. Next one, how many indexes can be calculated by the data which you have taken from the colorimeter. Okay, so first one is the Browning index. Browning index is commonly used to measure the of browning of food products such as coffee or meat during cooking. It's determined during using a colorimeter which measures the absorbance of light by the sample at different wavelengths. How you can calculate the Browning index? See, x minus 0.31 into 100 divided by 0.172. And this x value you can calculate by using this formula. In this formula, A, L, and B value you have to put, and in this way you will calculate the x value. That x value you put here, then you will get the Browning index. Means how much browning is your food product after the processing. Next one is the whiteness index. Whiteness index is a device used to measure the whiteness of an object or a material. Whiteness index, how can you calculate? That is the formula L minus 3 into B strict plus 3 into A strict value. So why it is important is that what is the importance of colorimeter? Color measurement tool can reveal minor variations between two colors. As you have seen the examples of tomato, there was a red color and orange color tomato, but visually you can see. But in some cases, there is minor differences which you cannot observe from your naked eyes, which is determined by the colorimeter, even if they appear to be the same to the human eye. When a sample's color deviates from standard, costs and rework are increased, and customer satisfaction is affected. For this reason, it's critical to detect color variations between a sample and the standard as early as feasible in the production process. Hope this video is informative for you. Thank you for watching this video. And if you have any query, you can ask through mail foodtechinsight@gmail.com.